then you won't have to worry about taking the exam.
PP test. I was going to say, you don't have to take the PP test, right?
Yeah. Well, I don't think we're going to have too big a deal to do that. All right. So first of all, everybody say hi to Laura.
Hi, Laura. Hi, Rachel.
Hi, Laura. All right. So the question, consider the following reaction in acidic solution. Manganese 2 plus, this is called sodium bismuthate. Yeah. Goes to form bismuth 3 and, what's that ion? Permanganate. Okay. We'll do the easy one first. What happens to the sodium in this reaction? No, it doesn't disappear.
Does it dissolve?
Yeah, it goes into solution. Like sodium in any ionic compound, it goes into solution and stays there. Okay? So, part of our balanced equation is going to be Na plus in some quantity. Alright, now balance the equation. We've got a whole page here to do that. So, before we do that though, let's go back here. Let's determine oxidation states. What's the oxidation state for manganese? Plus 2, obviously. For sodium? Can sodium ever be anything else? Well, it could be 0 if it was just the metal. Bismuth we'll get to in a minute. What about the oxygen? Minus 2. So the total negative charge is going to be minus 6. Sodium accounts for plus 1. What does bismuth have to be? Plus 5. Okay?
And you can do that?
What's that?
Is it like common food to be plus 5? Or just
Can.
like having, like, usually?
Well, bismuth is in group 15, right?
Right.
So it has 5 valence electrons.
Oh, so it makes sense.
Okay. This, what is it here? What's bismuth here? Plus 3. Oxygen, of course, is minus 2. What does that make manganese?
Plus 7.
Plus 7. Wow.
Yes.
That's a lot.
That's right.
But there we go. All right. So what is our oxidation reaction?
Is it manganese to permanganate?
So our oxidation will involve an increase in charge, right? That's going to be manganese 2 goes to make permanganate. Okay? And a reduction reaction?
Sodium bismuthate.
Sodium bismuthate goes to bismuth 3. Okay? All right. Those are our 2 half reactions. We can deal with either one of them first. Let's just deal with the permanganate first. So, we have manganese 2 plus going to permanganate. What's our first step?
Balance off. Well, the first step is balance manganese, but it's already balanced.
Manganese is already balanced. What's the next thing we got to do? Oxygen. So what do we have to do to balance oxygen?
Water.
Got to have 4 waters, right?
Yeah, that's what I was thinking.
Plus 4 H2O. Now what?
8 hydrogen ions on the right.
Got to have hydrogen on this side. There's a total of 8 hydrogens. So we've got to put 8 here. That's 8H plus. Now what?
Electron.
Balance charge. Okay? Total charge on the left is plus 2. Total charge on the right is plus 7. So what do we have to do to balance it? How many electrons and which side? Plus 5 electrons. Okay. That's one half reaction. Here's the other one. NaBiO3 goes to make Bi 3 plus. Okay? Gosh, I hope we have enough room on that side. Tell you what. Let's move that over. Okay. So, what's our first step?
Balance.
Balance everything except hydrogen, oxygen. What else do we have to account for here?
Sodium.
Sodium. And what did we say sodium was going to do? Dissolve. When sodium is in a solution, what form does it take? No.
Na plus.
It takes the form of the ion, sodium ion. So we're going to add Na plus. Okay? When sodium dissolves, it always exists as sodium ion, Na plus. All right, what else do we need? And how do we get it? Water, how many?
3 on the right side.
3 on the right side, okay? Plus 3 H2O.
6 hydrogen on the left side.
Now we're going to have plus 6 H plus on that side. What's the total charge on the right?
No, that's the left.
Plus 4.
Plus 4, okay? What's the total charge on the left?
Plus 6.
Plus 6. So what do we need?
2 electrons on the left.
2 electrons on the left. Okay? We've now balanced both halfway reactions. What is our next step? Balance the two of them with respect to each other. What do we use to accomplish that? Number of electrons. What's our least common multiple? 10. So everything up here we're going to have to multiply by 2. So 2 manganese. This becomes 8 water. 2 permanganate. 16. And 10 electrons. Okay? What do we have to do with this one down here? Whoa. That's funny. What do we have to do to make this one balance?
5.
Everything times 5. So this becomes 5 sodium bismuthates. This becomes 30 H plus. This becomes 10 electrons, 5 bismuth, 5 sodium, and 15 water. Okay? Now let's cancel what we can cancel and add them together. Alright. So, what can we cancel? Electrons first and foremost. Okay? 10 electrons gone, 10 electrons gone. The fact that we can do that tells us we can do everything else. What else can we cancel?
Water.
We could cancel some water, sure. We got 8 of them over here and 15 over here.
Do hydrogen first.
Doesn't matter.
Okay.
So let's get rid of those 8 waters. And over here we're going to get rid of 8, which will leave us with 7. Right? It's 15 minus 8 is 7. What about hydrogen ion? We have 16 of them over here and 30 of them over here. So let's get rid of those 16. Let's get rid of 16 of those. This becomes 14. Okay? Are these a little larger coefficients than you're used to dealing with? Yeah. Does that inherently make it any different? Not really. It just might make the numbers look a little more frightening, but they're just numbers. Okay? So,
Is there anything else we can do?
Anything else we can get rid of? I don't believe so. So let's add together what we've got. We have manganese, 2, 2Mn2 plus, so that's accounted for. We have 5 sodium bismuthate, so that's accounted for. We have 14 hydrogen, that's accounted for. The electrons we don't need to worry about. On this side we have 5 bismuth, 3, so that's accounted for. We have 5 sodium, that's accounted for. We have 2 permanganates, that's accounted for. And we have 7 water, so that's accounted for. Everything up there is now either underlined or crossed out. So what's our last step? Let's double check and make sure that it's balanced. Let's look at charge first. What is the total charge on the left? This is neutral, so it has no charge. This is 2 times 2 is 4, and 14, so that's 18, plus 18 on the left. 5 times 3 is 15. 5 times 1 is 5, that's 20. But we also have 2 negative charges here, so that's 18. That is a very good sign. If we've got the charge narrowed down, it's almost not possible that we don't have the mass balanced right. But let's check. Okay?
There might be an exception.
Manganese 1, 2. Manganese 1, 2. That's good. Sodium 5 sodium. 5 sodium. Good. 5 bismuth. 5 bismuth. Good. 15 oxygen. Okay? So over here we have 7 oxygen here. 2 times 4 is 8. 8 more oxygen there. That's good. And then 14 hydrogen. 14 hydrogen. And that, as they say, is that. How many got this?
Okay, I was like on a roll just from memorization,
Mhm.
and I forgot they had to like balance the electrons.
Ah, okay.
So
so-
then that screwed everything else up. But,
Yeah, if you don't balance out the electrons, you
but,
can't
like,
get past that.
process-wise,
Well, and that's what I would say. Work on process first. Once you perfect process, results will come. All right? Hang on just a second.